Hello and welcome to this tutorial on the face recognition system project. So in this project what we are going to do, so I'll show you with an example. So we are going to train our model uh, with this image, let's say this image. So what is this image about? This image contains the faces in various position, various under various lighting conditions of the former president of USA, that is Barack Obama. So we are going to tell to our system, train to our system that these faces are of the person called as Barack Obama. And then we are going to test the system with the unknown image, right? With a new image where the image will contain, let's say, the face of Barack Obama, and our system will plot or draw the rectangle around that system and that face, and it will name there as Barack Obama. For example, in this image, you see here is the face of Barack Obama. So our system will put a rectangle around it like this, and it will write Barack Obama, right? Again, in this, right, in this image, you can see our system will identify this is the face of Barack Obama, and it will write Barack Obama here. So that's the project. I'll summarize one more time. We are going to train our system with let's say 10 images, 10 faces in from different angles, with different expressions under different lighting conditions, right? And we are going to tell to our system that this face is of Barack Obama, this face is of Barack Obama, right? So all those faces belong to Barack Obama. And then we are going to give a new image, that is, let's say, this image, and we'll see whether our system recognizes the face in this image or not, right? Like our system should be able to identify this face as Barack Obama, right? So that's the project called as face recognition system. So here in this project, I'm not going to use any library, or sorry, any data set. So if you want, this is a very simple system where we are going to train our system with only going to train our system only for one image, right? So of course you can use a data set, right? uh, there are many open source data sets available, you can use those, right? But for simplicity, I'm using only one image here, right? Training image and testing image, right? So let us start importing some important libraries, right? So the first library is called as face recognition. So that face recognition library you have to import. Now it will not be there in your editor or the environment which you are using. So you have to, if it is not there, you have to do pip install face recognition, right? So so this library is getting installed here. Okay, you can see here this library is installed. uh, Now I can import it, right? I can import it by saying import face recognition, right? Then I'll need numpy, right? I'll need numpy, so I'll say import numpy, right, as np. Then I'll need OpenCV, right? So if you are doing it in Jupyter Notebook, you can simply say import OpenCV or import CV2. But if you are using Google Colab, you will have to import the CV2 from google.colab.patches. So I'm using Google Colab, that's why I'll say from google.colab.patches, google.colab.patches, import cv2.imshow. Now, why this CV cv2.imshow, this cv2 dot imshow function will work in Google Colab, and it will display an image. For displaying an image will require that, right? So if you are not using Google Colab, you can use a cv2 underscore imshow, which you can directly get from import a cv2, right? Okay, but if you are using Google Colab, you have to write this, right? Okay, let me execute this. This is cv2 underscore, by the way. So face recognition library is used for face detection and recognition purpose, right? So okay, all the libraries are available to us. Now we'll import the training images, right? Or in fact, we have only one training image. So I'll say training underscore image is equal to face recognition underscore load underscore training recognition. This is on face recognition dot, we are calling this load image function, load image file, right? And here I'll write the name of the file, right? So I have uploaded the file called as, I'll show you here, these three files I have uploaded here. One is barak.jpg, and these two for testing purposes, right? So if you are using Google Colab, again you have to upload your images here in this folder called as content, right? So these files are here in this folder called as content. So I have stored those files here, and so that I can directly give the name of the file, right? I need not give the path, right? So from that, those complexities I need not bother about those complexities. Okay, so the name of the file is barak.jpg, right? So this is the name of the file, right? And then so this file will be loaded, this image will be loaded into this variable called as training image, right? So and this, of course, this image will be stored as an array in the memory, right? It will be stored as an array in the memory, right? Array of pixels, of course. Then we have face encoding, training underscore face underscore encoding is equal to face recognition dot face encoding training image, right? So the image which we just uploaded, we are going to encode that image, right? So this function, right, face encoding function will detect the faces in the loaded image, right? That is this training image, right? So what this function does, the face underscore encoding. So this function will detect the faces in this training image, right? And then it will create the encodings for those images, right? So whatever faces are there in this training underscore image, those will be detected, and those will be encoded, right? And the encodings are, basically it's a simplified representation of the facial features, which can be used for comparisons, like for example the distance between eyebrows, right? So these kind of features are encoded in this face encoding, right? So what is the necessity of that? The necessity of that is those features can be later used for comparing the images, right? So okay, so we loaded the image, we encoded the image, right? So let's execute this. So face recognition has no attribute called as face encoding. So okay, it's encodings actually. Okay, so we have done this. Then we'll check if any face encoding is found or not in the training image, right? We will check whether the list is empty, right? That means if there is no face detected in the image, then the the list of training face encodings will be empty actually, right? So let's check if training underscore face underscore encodings, right? So we'll check here if the encoding, right? If this list, actually this is a list, right? So if this list contains some images, then only we are going to process with the process the detected faces, right? So if this list is not empty, right, then only we are going to process this mm, the images, sorry, the faces in that list, right? So let's see, right, if this is not empty, then we'll say we know that the face is of Barack Obama, so we are going to say that Barack, this is just a variable, Barack Obama face encoding, right? This is name of the variable in which I'm going to store that particular encoding, right? So training underscore face underscore encoding of 0, right? So 0 means the first encoding, right? First encoding in the list, first encoding in the list, right? So that I'm going to store here, right? So if there are multiple images out of that, multiple faces out of that, I'm going to store the first encoding which is on 0th place in this list, so in this variable, right? So okay, so let me, okay, oh, so so this I hope you understood this zero index. This zero index gets actually the first item from this list, right? So this is the Python list actually, right? Which is storing the encodings of the images, encodings of the, not images but the faces, encodings of the faces. Now if there are multiple faces, so those multiple encodings will be stored in this list, right? So out of that we are getting the first encoding, right? Okay. Then we'll store this face encoding for the comparison with the unknown images later, right? We'll store the face encoding. So what we did, we detected the face, right? And we stored that face in this variable, right? We detected, encoded, and stored the encoding in this variable, right? Now we are going to store this face encoding for the latter comparison, right? So for example, I'll say known face encoding is equal to Barack Obama face encoding, right? Barack Obama face encoding. Okay, so what we are going to do, we are going to create a list of known encodings, known faces, right? So now, as of now, we have only one encoding. We have only one encoding, so I have stored this here, right? So, and then the second list I'll create is known face names, name of that encode, names of those faces in the encoding, right? So the name here is Barack Obama, right? So what we did, we created the two lists, right? The first is known face encodings and the second is known face names, right? So one for the face encoding and the other for the corresponding names, right? So we can use this lists latter to identify the person, comparing the unknown faces against this known encodings, right? Okay. So then we'll load the unknown image and process it, right? We'll load the unknown image, right? After doing the encoding of unknown image, we'll do the right? So unknown, this is unknown image, right? Unknown means a new image, known underscore image, face recognition dot load underscore image file, face recognition dot load underscore image file, and here we'll pass the unknown image, right? So the unknown image here for us is Barack test dot jpeg. See, both these images, Barack.jpg and Barack test.jpg, I have uploaded in Google Colab. So this will be a temporary uploading, right? That means once you quit this program, this uploading, these images will be removed, right? They will not be permanently stored in Google Colab, right? Okay. So this is unknown image, which is uploaded in this unknown image variable, right? Then we have unknown face. We want to find the location of the face in the unknown image. Unknown face underscore location, right? So we want to find the locations rather, right? Locations of the faces in the unknown image, right? We want to locate the faces in the unknown image. See, unknown image may contain many things, no, but we want to locate the faces, right? So how will we do that? Again, by using face recognition. RECOGN, yeah, face recognition dot face underscore locations, face underscore locations, right? So, and here we'll pass this unknown underscore image, right? So this will locate the faces in the unknown image, right? Then we will encode those faces, right? Unknown face encodings is equal to face recognition dot face encodings, right? We'll encode those faces, right, in the unknown image, right? So unknown encodings, to this will pass unknown image, comma, the locations, right? So what we did here, so we have this unknown image which we uploaded by using face recognition dot load image file. The name of this image is this one. Then we detected the faces in that unknown image, right, by using this face recognition dot face location function. Then in that those faces are encoded, right? I'm sorry. So those faces are encoded by using face encodings and stored in this unknown face encodings, right? Okay, so that's what we have done so far. Now what will we do? So we will convert the unknown image into what is called as BGR color space, right? Why? Because face recognition library works with the works in the RBG colors, RGB color space, right? This face recognition library works with the RGB color space, right? Whereas OpenCV works with what is called as BGR color space, right? So this face recognition, now we want to display that image, no? We want to display that image, right? That's why we need to convert the RGB image into what is called as BGR image, right? Why? Because OpenCV works with BGR color space, right? So let me do that. Okay. So unknown underscore image underscore BGR now. Right, we are converting the unknown image into BGR. So CV2 dot, right? So CVT color. There is a function called as CVT color. So that will convert one color space into another color space, right? So unknown unknown underscore image, comma cv2 dot color underscore rgb to bgr, right? So that will convert rgb to bgr, right? Okay, so now what will we do? We have this unknown faces, right? Unknown face encoding, right? So we will do over this detected faces. See, this unknown face encoding contains many faces. No, it contains many faces, right? Because there might be many faces in this image, right? There might be 4, 5, 10 faces, right? So these are stored in this unknown face encoding, right? Now we will loop over that faces one by one, right? And we'll identify or we'll while looping over, we'll compare this unknown face, those faces with the known faces, right? So what we are going to do here, this unknown face encodings, this is containing many faces image from this image, right? So we are going to loop through those faces one by one, right? And while looping through, we'll compare that face in the unknown image with the known encoding, right? That is known face, right? And if we find a match, we'll put a rectangle around that image. We'll put a rectangular box. We'll put a rectangle box around the this face in the unknown image, right? Okay, so let's write the code for that. For top, comma right, comma bottom, right, comma left, comma face underscore encodings in zip. So what is this zip function, right? So zip is used to uh, 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 in fact pair each of the face location with its encoding, right? So let me complete this. So zip unknown underscore face underscore locations. So we are going this face location contains the locations, right? So comma unknown sorry, unknown face encoding. So what we are going to do here basically is we are going to iterate through two lists simultaneously, right? That is the unknown face locations and the unknown face encoding, right? So this zip function allows us to combine these two lists, right? So that means this zip function allows us to iterate through these two lists simultaneously, right? So these unknown face encodings are getting into this face encodings, right? And these unknown face locations are getting stored into this top, right, bottom, and left. So this is getting unpacked. This is getting unpacked into this top, right, bottom, and left, and this unknown face encodings are getting stored in this face encoding, right? So these are the variables to loop through these lists, right? So these variables will loop through this unknown face locations. Now you will see this is one variable, and here there are four. So this is getting unpacked into these four variables, right? And this is getting into this face encoding, right? Okay, so let's loop through this, and while looping through this, we'll compare the faces, and we'll be assigning the names, right? So matches is equal to, right, matches face recognition dot compare face compare faces. We'll compare the faces with the known faces, right? Known face encodings, right? So this face, known face encoding will be compared with this face encoding, right? So this face encoding is containing the unknown faces, right? Unknown faces encoding is here, right, in this list, and this list we are iterating through this list one by one. That means one face at a time. So this face encoding will contain one unknown face at a time. So this unknown face will be compared with the known face, right? So unknown face is here, unknown face encoding, right? Okay. So then we'll compute the distance between the faces, right? Phase distance is equal to face recognition dot face distance. We are going to store the distances between the face, comma, in the bracket known face encoding, known face encodings, comma, face encoding. Right. So what we are doing here, we are computing the distance between the known face and the unknown face, right? So that distance is required. So later, you know, later, you know, we need to find the closest matching face, right? So that's why this phase distance is used to determine which known face encoding is closest to the current face encoding, right? So this is for that purpose we are computing the distance, and then we'll find the best match index is equal to np dot argmin face distance. So what we did, we are finding the index of the smallest distance, right? So what this phase distances is storing the distances between these unknown face, this known face and the unknown faces, right? So this phase distance is storing the distances between the known face and the unknown faces. So we want to find the least distance, right? That means to the known face is matching to that particular face, right, with least distance, phase distance, right? So let me call it as distances because there are many distances here. Okay, so best match we'll get, and then we'll see if matches of best match index, right? If matches of best match index, then we'll say name is equal to name is equal to known underscore face underscore names best match index. So we'll find the best match, right, and the name of the best match will be, you know, will be the name of the known faces, right? So we'll go in the known face names, we'll go in the known face names array, right, which we have created here, known face names, right? We have stored this, right, and we will pick the best match name, best match index name from there, right? So we are going there and picking that name, and we are giving that name to the name of the image which is closely matching to our image, right? Okay, so after that we'll draw the rectangles and labels around the detected faces, right? So the next step is to draw the rectangles and labels, right? So CV2, now here we'll use CV2 dot rectangle unknown known underscore image underscore bgr, right? Bgr because CV2 does not works with RGB, right? So BGR we have already converted. So left, we are going to put a rectangle around that unknown image, comma right bottom, right? So 0, one more bracket here, so 0 comma 0 comma 255, right? So that uh, BGR rectangle, right, red color rectangle we are going to put here, and 2, right? So this is the width of the rectangle, right? And then CV2 dot rectangle unknown unknown image BGR, right? Unknown image BGR. So this rectangle we are plotting for the text left comma top. We are specifying the left top. Uh, okay, so left bottom will specify here. Left bottom comma bottom, right? So this specifies the top left corner and right bottom corner. So this specifies the bottom left corner, right? Bottom left corner, and we'll have the space between this rectangle and this rectangle by pushing it up by 35 pixels, let's say 35 pixels, comma, we'll mention here the right bottom, right comma bottom, again 0 comma 0 comma 255, right? 0 comma 0 comma 255, again that will be the red rectangle, which is field rectangle now. CV2 dot field, I'll say CVT dot field, right? So that's the rectangle for drawing the labels, right? For the labels. Okay, then we'll have font is equal to we'll say font now. Font is equal to CV2 dot font underscore HERSHEY duplex. This is the font which will be using for plotting the label of the image, right? So then CV2 dot put text will put the text now, that is the label, unknown image underscore BGR comma name, right? Name which we got from here, right? So this name, comma left, we are now telling the locations, left 6 comma let's say bottom -6 comma font comma 0.5. So then we'll specify the font, we are specifying the font here, and the size of the font, and then we'll specify the font color also. So 255 comma 255 comma 255. So this is the font color, and let's say the width of the font is this one, right? So we have mentioned what we want to put a text around this unknown image, right? We specified the location, right? The font, right? Now after this we'll come out of this for loop, right? So we have been Yeah, we have been here in this for loop, right? So in this for loop, so after this, after coming out of the for loop, we'll display the image, right? So cv2 underscore im show, and to this we'll pass the unknown image. It's bgr, right? So we'll display that image. So this is what we'll do when we have found the found some image, right? If we have found some image, then only we'll do this. If there is no image, then we'll go in else part, right? And that is else part will say print no image, no faces were found in the training image, right? Okay, so I hope now let me run this big code here. Okay, training face encodings is not defined. Training face encodings, right? Yes. Okay. Module face recognition has no attribute face location. Face locations. CV2 is not defined. CV2. Okay. Let me run this. Face encoding is not defined. Face encodings. Okay. Okay, so here is the mistake encoding. Okay. List indices must be integers or slices, not str. Best match index. Okay, so this should be yeah, I made a mistake here. Oh yeah, great. You see, this is our test image, right? And this test image, in the test image, we are able to recognize the face of the person as Barack Obama. So now let's give another image, right? So we give Barack test. So Barack test 2, right? Test 2. What is test 2? So this is test 2 actually. This is test 2, right? So in this image also, we should be able to recognize this face as Barack, right? So I am giving test 2, right? So test 2 now I am giving. Oh yeah, you see, face is recognized here, and it is also labeled as Barack Obama, right? So this white color, because of we use the font color as 255, 255, 255, right? So that's why. So again, one more time testing will do. Barack test, right? So the first image, right? Yeah, so we are able to recognize that image face in the image, right? Okay, that's a simple project. Now I use only one image for training and one for testing. So you can go ahead and use the dataset. Probably in the coming videos I'll do that also. I just wanted to make this code very simple, so that's why I use a single image, right? So thank you so much for watching. I hope you understood the project. The project is uh, in unknown image. We want to put a rectangle around the face, which we are able to recognize based on the knowledge given to us earlier, right? Okay, so thank you so much.